Hey guys, welcome to DevOpsSchool. These days, everything is happening in the cloud. Cloud computing is a big shift from traditional way businesses think about IT resources, and Amazon Web Services is the world's broadly adopted cloud platform. So today, we are going to learn about AWS. But before we begin, let me inform you few things about us. DevOps School is one of the leading platforms which offers DevOps, cloud and containers technology training and certification programs for freshers and established professionals who wish to update and consolidate their skills in the dynamic IT scenario. We ensure that the training solutions are delivered by highly experienced domain experts with practical working experience in various verticals. You can join our all training programs globally through online platforms, and if you're looking for classroom workshop, then we have regular batches available in Hyderabad and Bangalore. Check out the dates and enroll with us for our upcoming batches. For more info, link and contact details are mentioned in the description below.
So any idea about the cloud? What is cloud?
I'm aware of cloud.
Okay. And what is on-premise infrastructure?
So the on-premise infrastructure is more of a legacy structure that we used to have. Now, as the development environments are, the product development environments are going through independently deployable applications to meet the faster time to market, we are looking at deploying our applications through either PaaS, our infrastructure, our service components to deploy them on an external cloud, whether it is private or public. To have the application availability more and more. And during the process of it, DevOps is more of enabling each and every phase of the cycle to automate and ensuring it. Every phase we have a great objective.
Correct. So why your on-premise infrastructure is not able to handle all these things, and why infrastructure as a service can handle all these things? What is the reason behind it?
There are multiple reasons, such as when we are looking at the legacy or on-premise systems, we have a lot of legacy code or ancillary code that we have. For example, even for deployments, instead of using a modernized tool versus we use legacy and scripts or some shell scripts, so forth, so on. It's more of a process thing, at the same time, modernizing your deployment process versus utilizing the existing stuff. When you have a legacy build in your own infrastructure, it's slightly difficult to maintain and run with as fast as the development teams want it, or the business wants it to go to the production.
Correct.
Absolutely. Manual efforts, right?
Yeah. So basically, what is cloud? A cloud is nothing but you buy some resources over the internet. You access the resources over the internet or internet.
Mm-hmm.
On-premise infrastructure, what happens? You need to buy a data center, you need to build a data center, you need to purchase all the resources what you are required to use. So when we talk about the on-prem infrastructure, we need to think about the data centers first of all. We need to think about managing the data centers. Managing the data center is not an easy task. Secondly, here you need to come with the exact figure about how many server storage you will require. 10 server, 20 server, 30 server, whatever is required, the number of GBs of storage you require. You need to come with the exact figure, and you need to buy everything on front. You need to first of all buy all the resources, then you need to configure, and then you will be able to use your servers for the actual infrastructure. Now what happens in the cloud? You don't need to buy anything here. Everything is pay-as-you-go model. The amount of resources that you will require, you can just initiate those number of resources, number of GBs of RAM, and etc. And as long as you are using the services, you need to pay. Once you stop the services, you are not going to pay anything here. You will not get charged for anything that you are not consuming. So here, everything in terms of fees, in terms of pricing model, you pay only for what you use. So that is a benefit of cloud.
Right, infrastructure as service, more of.
Right. Now, when we talk about the on-premise infrastructure, here you cannot come exactly how many servers is required. Let's say right now your requirement is only 2 server, but you know that once your services go live, once your project goes live, you will require 12 servers, let's assume. So you need to buy the 12 servers now or later to make sure that your services are up and running. In case there is a high, spike in your infrastructure, maybe someday there is a flash sale or due to some reason there is a high spike. And in that case, if the 12 server is insufficient to deliver the load, then the entire website will go down. Your application may go down. But here on the cloud, you do not have such kind of restrictions. As of now, if your requirement is only 2 servers, then you can just go with a 2 server. Once your project goes live, and if you want to extend the size to the 12 server, within only a few clicks, you can do that. You don't need to worry about everything. You have to just expand, you have to just replicate your servers across 12 different servers, which can be done within few clicks here and there. So extending the size of the infrastructure and downgrading your infrastructure at the same time can be easily done with only few clicks. So let's say right now I'm in a test environment where I'm running only 2 servers. Let's say this goes for next 1 month. So for the entire 1 month, I'm just going to pay for the 2 server. Whatever the cost will be associated for the 2 servers, I'm going to pay only for that. Once my servers is up and running for the live project, then the number of consumption that I will do for the next 12 servers, whatever the cost will be, I will pay for that. Here, initially, I don't need to initialize 12 server. I will start this 12 server whenever there is a requirement. Same goes for the storage, database, and everything. You pay only for what you use. So that is generally a cloud. Now in the clouds, there are varieties of vendors available in the market. And these vendors includes Amazon, Google, Azure, a lot of other things, a lot of vendors are available. So every cloud is having a specific purpose for delivering the workloads. AWS is specifically designed for infrastructure as a service. And when we talk about the infrastructure means 4 components: compute, storage, networking, and database. These 4 include in a part of an infra. Whenever we use the word infrastructure, we are just talking about the computing, storage, networking, and database. With these 4 core services, you can design anything here. That may be your big data application, that may be your machine learning, or just a normal e-commerce web application. Whatever it is, with these 4 core services, you can design anything. And AWS is specially designed for delivering the infrastructure as a services, in delivering these 4 computing services, these 4 core services to you. Now, apart from that, AWS also offers you 100 plus of managed services. This can be called as platform as a service or function as a service, whatever it is, or service directly. In this managed services, these are generally used managed services where AWS will create the resources, where AWS will manage the resources, and you can have to just interact with the services. For example, load balancer. Now, usually what you do, if you want to load the balance between multiple EC2 instances, you will create another machine and you will install load balancer in that. Now, this particular machine will have certain restrictions, like the computing power. Maybe it has only 2 core CPU, 2 GB RAM. So till that limit, this system will work, and if you get more requests on this particular machine, this EC2 install will fail to perform, this load balancer will fail to perform. Even if your load balancer fails to perform, the entire architecture will fail to perform. So then AWS has designed its own load balancer called as Elastic Load Balancer. Elastic Load Balancer will automatically scale to any limit. It can handle millions of requests per second. It can handle. So if you have hundreds of requests or millions of requests, This ELP is a AWS managed service which will automatically scale at the background to meet the requirement. If there is 100 requests, it will scale to meet that requirement. If there is a millions of requests, it will scale to that limit. So here you don't need to worry about creation of a server, installing of a load balancer, config the machine, anything. You get a direct end-to-end service. So this is managed service in general, where AWS manage the resources for you. AWS will create a resources for you and configure it available. All right. So this is when we talk about these 4 core services. Here you need to configure everything. Here you need to create a server. Here you need to boot the system and do all the configurations. But when we talk about the managed services, AWS manages it for you. That is usually the difference between our core services and managed services. Now, do you have AWS account?
No, I don't.
Right. So you can just go to the link, AWS account. With this link, you can create an AWS account from here. Top right corner, you will see sign into the AWS console, and then you can create an AWS account. I'll share the link with you. And what AWS offers you, AWS free tier. Once you open this account, you will be entitled with a free tier. Now, basically, when you are creating a new account, basically it will ask you for the credit card or debit card details, and it will deduct 2 rupee INR or $1 USD from your account, which will be refunded back within 13 to 14 days. Just to verify your bank details, they deduct. Then once you have an AWS account, there are 12 months of free tier eligible for it. Now in this 12 months of free eligibility, whatever the resources that you will create, that will be completely free. But you need to be you have to be within the limits. Like your EC2 instance, the compute capacity, you get 750 hours per month. And you need to stick with the T2 micro machine. So what we have is 750 hours of T2 micro machine EC2 instance. So every month for the next 12 months, you will get 750 hours of free EC2 instance if you stick with a T2 micro. What is T2 micro? T2 micro offers you 1 core CPU and 1 GB RAM. So if you stick with this limit, then whatever the resources that you will get, that will be completely free. Now you get 750 hours per month. What does that mean? If you run one EC2 machine for 24 hours, then total consumption is 24 hours. If you run two EC2 machine of T2 micro for the next 24 hours, then that means 48 hours is consumed. Out of this 750, 48 hours will be consumed. So the number of EC2 that you are running for the amount of hours, it depends on that. So it's the best way that once you are done with the lab, just make sure you delete all the resources what you have created at the earliest. And you can just use this link.
That's the system uptime, right? System uptime or the usage time?
Yes.
Okay.
So you can just go through this link and check out all the services who are available for free, like S3, 5 GB, RDS again, 750 hours, and all other things. There are certain resources which are always free. Even though you have completed your free account, then also these services are also free lifetime. 25 GB of DynamoDB every month, 1 million Lambda requests, 1 million SNS requests. These services are always free, even though you exceed the free tier. And now once you log into the AWS account, this is a management console that you will see. Now in this management console, if you click on all services here, or if you just click on the services, you will find all the AWS services. So you have a group of services in the computing section. There are varieties of services in storage, databases, migration, media services. You have a very big list of machine learning. So if you are dealing with the machine learning services, you don't need to create all the services here. Here there is by default services available. You can just interact with the service. Lex, Poly, Forecast, then Translated, Amazon Translate for translation of language, IoT services, big data analytical services, a varieties of services are directly available. So you don't require to design such kind of application. The application is right away available for you. So our first point to discuss is global infrastructure. Now AWS infrastructure is divided into multiple data centers. These are first of all regions. A region is nothing but a geographic location. Like there are certain regions in US, certain regions of Asia, etc. If you see on the AWS console at the top right corner, you will find all the regions. As of now, there are 22 regions worldwide. You have a US East North Virginia, Ohio, California, Oregon, Hong Kong, Mumbai, etc. So you have 22 regions here worldwide available, and you can design your infrastructure in any of the region. You should choose a region which is nearest to your customer always, so that the customer can access the data easily. The latency will be less. So you should design the infrastructure which is nearest to your customers. There are 22 regions available, and out of that, 3 regions are not eligible or you are not available. These 3 regions are specifically designed for US government and China government. So you cannot design the data centers in, or you cannot design the infrastructure in those regions unless you are designing for the government. In that case, also you need to request to the AWS, and you need to follow up all the procedure. Then you will be able to allow it. So out of these 22 regions, 3 regions is completely available for US government and China, and you will find the rest of the 19 regions here. Then, in a particular region, there are many availability zones available. A availability zone is nothing but a group of data centers. And in this data center, you will be actually designing the infrastructure.
What is availability zone? Group of data centers. Okay, got it.
So, like for example, we have a region called as Mumbai, and in Mumbai we have 3 availability zones: AZ1A, AZ1B, and AZ1C. So I can design the infrastructure in 1A or 1B, 1C, or in conjunction of 1A, 1B, and 1C. So what will happen? I can design my infrastructure in multi-AZ, and the benefit you will get is high availability. If you design the infrastructure in multiple availability zones, let's say you need to create a 10 servers. So you create a 5 server in AZ1A and 5 server in AZ1B. In case if there is a downtime is there, or maybe the hardware failure or the entire AZ goes down, this AZ1A, then the resources created in AZ1B will be still up and running. So your website in that case will never go down, and in this case you can increase the high availability of your infrastructure. So whenever there is a question comes is that you need to increase the availability of your infrastructure, the best way is to design your infrastructure in multiple availability zones. Now in this case, your data center will not leave the region. The entire data centers will be in the Mumbai infrastructure. It will be in a country, specific country, that is in Mumbai, but into multiple data centers. AZ1A is a one data center, AZ1B is another data center, and AZ1C is another data center, which is completely isolated and separated from another data centers. So we have here 3 availability zones, and AZ1A, AZ1B, and AZ1C. Depending on the regions, you will find different number of availability zones. In North Virginia, you will find 6 availability zones. In Singapore, you will again find 3 availability zones. So depending upon region to region, you will find multiple availability zone, and at least of 2 availability zone you will find in all the region. At least of 2 availability zone you will find in all the region.
So you can create a single availability zones or multi-availability zones. Is that right, Lalit?
Sorry, once again.
No, the availability zones. You can create single availability zones or multi-availability zones.
You can design single availability zone or multiple availability zone, whatever is your scenario.
Got it.
And the third global infrastructure is called as edge location. Now, edge location is a location where you cannot design the infrastructure. This edge location can only hold your cache content. So if you want to cache your data, then we have an edge location. So do you know what is content delivery network, CDN?
No.
A content delivery network helps you to cache your data and spread across the world. For example, there is a person sitting in UK who has uploaded a video, all right? And I am sitting in India trying to access the video for the first time. So here my network needs to travel to the UK to get the data. Let's assume my network requires 400 milliseconds to get the data from UK, come back to India, and to deliver the content. Let's say it takes 400 milliseconds. So every time a user will hit to the server of a UK, it will take approximately 400 milliseconds to deliver the content. Now instead of that, what we can do is we can introduce a CDN. So I will forward the request to the UK server that I need this particular data. So the server will forward the data to me directly, as well as it will cache the data to the Indian edge locations. So that next time any Indian user trying to access the same data, they don't require to go to the UK. They will get the data from the Indian cache location, Indian content delivery network. So in this case, the latency will be reduced. The rest of the people who will access the data, that latency can be decreased. And if you see, these is the most common user service. Now, content delivery network on the AWS is called as CloudFront. This CloudFront service is one of the most popular service on AWS. If you see Netflix, Amazon Prime, Hulu, Pinterest, Instagram, then Snapchat, and various of other media-related services are using this CloudFront network to deliver the content. So let's say, Netflix example, they are running hundreds of thousands of servers. So every time a user hit to those, user wishes to watch the series or movies, they hit to this server and they get a data here. So if they introduce now CDN network in middle of it, do they need to have thousands of server again?
No, because the data is almost, first request it pings the data from the original place, and then second request onwards it doesn't go to the originator. It basically comes from the local.
Correct. So whenever the next user will hit to the data, they will not hit to the server. They will get a data from the content delivery. So in this case, they can reduce the size of the server. When they are decreasing the size of the server, they can save a lot of cost here. And at the same time, it can increase the user experience because the data is available right next to their location, so the experience will be better. Even Apple, Samsung, and MI, these are also using this CDN network to deliver the software patches. Whatever the updates that you get, these updates are also you get from a CDN network nowadays. So content delivery network is really very important service here.
Yeah.
So these are the three global infrastructures: region, availability zone, and edge location. And this three global infrastructure is a responsibility of AWS. If anything goes down, if anything needs to be upgraded, then Amazon will take care of it. You don't need to worry about anything here. So this is a global infrastructure. So let's start with the first AWS service called as IAM, which is Identity access management. This is the first service which can help you to create an identity on your AWS account, can control the security. This is the first layer of security. Now, usually what happens when you create an AWS account, you are not only the person who will be designing the entire infrastructure. You will have your team members, you will have your colleagues who will be, helping you to design the infrastructure. So how will you share the credentials with your team member? How will you give them access to the AWS account? So for that, we have IAM service, and this IAM service will help you to authenticate and authorize right person to have access to your account. IAM service is only for the authentication purpose and authorization purpose. To authorize your users and identity, you can use the IAM service. Now it includes 4 components. First is user, second is group, third one is role, fourth one is policy. These are only 4 components of IAM. What is user? A user is nothing but any physical person in your team who wants to have access to the AWS account. You will create an IAM user. You are just creating an identity on AWS that this person can have access to the account. So there are 3 different kinds of user. One is IAM user, second one is federated user, and third one is root user. A root user is nothing but when I create an AWS account, the username, the email ID, and the password which I have set, that is nothing but a user account, root account. This root account will have a complete privilege, total privilege. They can have access to all the AWS services, including the billing dashboard and organization, everything. It will have complete control on AWS account. And that's why it is recommended that you should never use this root account. You should terminate the root account once you start working on the AWS. You should never use, or you should remove, or reduce the consumption of a root user. Because if these credentials are compromised, then it will lead to a lot of problems here. Then we have 2 more identity. That is, first of all, an IAM user. You can create an IAM identity for every physical person in your team member, and you can assign them whatever the permissions is, you want to assign. And there are federated users. Federated users can be of again 2 types. One can be from your Active Directory. Your organization may be maintaining an Active Directory. So if you want to import a user from the system so that the credential will remain the same, the username password which is already been set in your Active Directory, if you want to import the same credentials to the AWS, you can use the Active Directory. Microsoft Active Directory or LDAP Directory, both are supported. The second kind of is federating users from an existing location, from existing directory. That may include Facebook, Google, Amazon. So if you want to sign up, if you have such kind of application where user is signing up from this identity system, maybe from Facebook, Google, or Amazon, and if you want to give access to these users to your AWS account, then that also can be possible. So whatever the identity is available on this particular website, this identity will be shared with you on AWS, and whatever the permissions you want to assign, you can give it. Yes. Yes, anything you are asking?
No, what I'm saying is more or less the single sign-on user.
Yes. Sorry, I didn't get you. What exactly?
A single sign-on SSO user, like
Yes.
he can log in with external IDs.
Correct. Single sign-on user. So what is your case? In that case, you can import this identity of the AWS single sign-in. You can import. and you can define the permissions whatever you require. You can import the users from your Active Directory. You can also create your own identity system, identity on the AWS, or you have a root users. Then basically what happens, you have a group of users. Let's say you have hundreds of users. So you need to create hundreds of users identity and you need to go to each of the users to assign the permission. So for my user 1, I need to attach permissions of EC2, let's say S3 and the VPC. So I need to go to each of these users and assign all the permissions. So in future, if I want to change a permission, if I want to add a permission or I want to revoke a permission, then to all the hundreds of users, I need to go to each of these users and assign it, which is not an easy task and it will take a lot of time. So what you can do is you can create a group and you can add multiple users into a group. And you can assign the permission at the group level. Group level permissions you can define it here. So whatever the permission you will attach to the group, all the users inside that group will get the permission. So in case in the future, if you want to add a permission or revoke a permission, on a single click, whatever the changes that you do under group level permission, that will be applicable. Now a users can belong to multiple groups. A user can belong to group A as well as group B as well as group C. There is no limit for that. A user can belong to multiple groups. So if you have a different permissions at the different groups, and if a user wants to be a part of all the groups, then you can add it. There is no condition at all. Now, user can be part of group. That's okay. Then we have a role. Now to understand the role, basically two AWS services cannot talk to each other. The number of services that we see are on the AWS services, any two AWS services cannot talk to each other. Your EC2 instance cannot talk to the S3, your S3 cannot talk to the VPC at all. Two services cannot talk to each other. You need to specifically define a role to authenticate, to authorize, to permission. So to authorize AWS services, you will require a role. You create a role and you define the permission. That is, let's say EC2 can handle or can access to the S3. S3 can talk to the EC2 instance. S3 can talk to the DynamoDB. Whatever is your scenario, you need to create a role. Now in general, let's assume a scenario. You have an EC2 instance running, and in this EC2 instance, maybe let's say you have a PHP code running. And then you have an RDS machine where you are running a MySQL server. So usually if this PHP server, PHP wants to write some data on MySQL, or maybe it needs to read some data from the MySQL, how will you do the authentication? In general, how will you connect the PHP to the MySQL?
So you create a role, a user with a different role, so that the user can go write or read permissions.
Let's just skip about the AWS part. In general, if you have a PHP application that needs to talk to the MySQL, how you usually interact?
A simple PHP code that is a program that is going to read or write on MySQL to be a database user.
But how you will authenticate this PHP to talk to the MySQL? Because when we create a MySQL database, we need to provide the username, passwords, and everything. Correct. So that all the details you need to hardcode in your PHP application, right? So you hardcode everything, the credentials in your PHP application that will make a connection to the MySQL, and then it will have a read access, write access, whatever is required. Now, hardcoding a credentials on the AWS is not at all recommended, and it is not a very good practice.
Yeah, anywhere it's not recommended to hardcode the values, right? So exactly. I think the user should be part of both the groups, EC2 as well as the DB group, so that the user can have both permissions on both the groups.
Correct. User should be a part of a EC2 instance as well as the RDS. But here, the user is not making a request to the PHP via, the user is not making a request from PHP to the MySQL. The application code is making a request to the MySQL. So instead of you define the permission to the user that you have access to the EC2 instance and the RDS, basically you assign the permission to the EC2 instance. Yes, you can talk to the RDS. I give you permission. That is what we have a role, authorizing AWS services. So here I authorize my PHP application, that is my EC2 instance, to have a permission that you can talk to the RDS. So once I attach the role, now I don't require to hardcode the credentials anymore. Without hardcoding the credentials, now this EC2 instance can talk to RDS or whatever the scenario is, EC2 to S3, S3 to Lambda, DynamoDB, whatever is. Between two AWS services, once you assign the permissions, once you assign the IAM role, now you don't require to hardcode the credentials.
Got it. Yeah.
Right. So we have here users, groups, and role. On a user, we do authorize the users via assigning a permission. Group level, we also assign a permission, and as well as role, we also assign a permission. So what exactly these permissions are? These permissions are nothing but a policy, and policy is nothing but a JSON document. 1 second. Okay. So this policy is nothing but a JSON document which defines the permissions here. So for determining a permission policy, there is a specific rule. Like first of all, you need to provide the version. And version is usually defined by the AWS, which is 09 or 17, something is there. Once you go to the AWS console, you will find what is the latest version is. You have to deal with that. And then here you can define the statement body, what exactly the permissions you want to have. So the statement includes first part is effect. And these two conditions allowed. One, you can have it allow or deny. And effect can be an allow or deny, whether you are allowing the user or whether you are denying the user. Second, you have an action. What actions you want to allow? EC2 full access, EC2 read-only access, S3 full access, S3 read-only access. So whatever the services you want to assign, whatever the actions you want to allow the user, you can have a list of all the things here. Third is the resources. Now you want to do on the all the EC2 instance of the EC2, whatever the permissions you want. Let's say my action is start instance. So the start instance actions, do you want to apply to all the EC2 instances in your AWS account, or you want to be specific with this particular instance ID? So you can define a particular instance ID here, or you can define a star that will consider as all the AWS EC2 instance. Similarly, whatever the actions you want to define as a create bucket, let's say create S3 bucket. So do you want to define on a single S3 bucket, or do you want to do on the entire AWS resources? So resources define a single particular resource, group of resources, or to all the resources. Whatever it is, you can define it here. So basically, these are the three things that you include in your policy document. There is a fourth part available, which is called as principle. Principle. Principal is something that you don't need to define. This will be automatically taken to the place. Now, what is principal? Basically, you create a document like this, and if you attach this document to a user, that is, let's say, I am giving a user to have access to the EC2 instance, complete control. So if I attach this permission of EC2 instance to a user, then the principal will become a user here. That may be a specific user, let's say Amit. So only Amit user will have access to the EC2 instance complete control. If I want to give at a group level, then the principal will automatically become a group. Let's say group admin, whatever the name will be. So admin user will get a complete control of the EC2 instance. Now in a group, whatever the number of whatever the IAM users are available, all the user will have access to this EC2 service. If you attach this permission document to a role, then this will apply to a role as well. So let's say you are defining this permission to the S3. So if you apply the permission to an S3 role, then S3 can talk to the EC2 instance now. So if you apply a permission document to a role, then the role will be applicable to the AWS services. If you apply this policy document to a group, then the user will have access to it. If you want to be very specific, then you can add a users. So permissions, this principal part will automatically apply to the number of resources that you are connected, number of identities, entities that you are connected. It will be automatically applied.
And you mentioned principal has a default value too, like right, Lalit? So if I don't specify principal, by default it allocates or implies this policy to all the users who are connected are part of the group.
No, when you create a users, groups, or role, no permission will be attached by default.
Okay.
You need to define it for yourself.
And
whenever you create an IAM user, the permission will not be applicable. Any kind of permission will not be given to the user. The user will be completely blank without zero permission. You need to specifically define which permissions you want to have, EC2, S3, whatever it is required. Same applies to a group, same applies to a role. By default, there will be permissions that are given to the users.
And how about the principal then?
Once you create a policy, when you attach this policy to a user, then the principal will automatically become the user. If you attach this policy to a group, then the principal will automatically become a group. So that is something that automatically changes whenever you increase the number of entities where you attach this document. So this will automatically take into action. Now a principal can be another AWS account as well. If another AWS account user want to have access to your AWS account resources, then it can be another services as well. That also you can give. So here you need to define the 12-digit account ID, and whatever the specific user or a group, whoever wants to have access to the AWS account, they can have access. So the particular user will have access to this EC2 instance in your AWS account. This is called as cross-account access. So that is something again you can create. Now by default, everything on AWS is restricted. There is no permission attached to a user's group or role. Everything is restricted. The user will not have no permissions at all. So let's say there is a user who is trying to access to the EC2 instance. Of course, right now the user is not having any specific permission. And when he tries to access to the EC2 instance, he will get an access denied message. So how AWS will work in this case? AWS first of all checks whether you have explicitly defined any denied permissions or not. If you have denied explicitly that the user is not allowed to have access to this particular service, then the user will get an access denied. If you haven't defined any explicit rule that the user is denied, then AWS will check whether you have explicitly allowed the user or not. If you have explicitly allowed the user to have access to these services, then the permission will be given. If in that case you have not defined the allow rules, or if you have not defined the deny rules, then by default it will be again deny.
Okay.
Right?
So explicitly we have to provide
Exactly.
what are the rules that are applied to a user. It doesn't mean that a user has been created and some of the privileges or permissions
Yeah.
are allowed. All of them
No.
are protected mode, bottom line.
Yes, by default everything is denied on AWS. Always the highest priority will get the deny rule. Deny rule will get the highest priority always on the AWS. No matter whether it's a user, groups, or role, everywhere deny will get the highest priority. So let's say if you have a user and is this user you have attached two policies. One policy allow the users and second policy deny the user. So in this case again the second policy will get the highest priority. Always deny get the highest priority. Okay, this is something that you need to very carefully do with these things. That always deny rule will get the highest priority.
So okay, one quick thing, Lalit. So when you're saying user allow and user deny, why would we do both of them at the same user anyways?
You will not do basically. Sometimes what happens, a user is a part of a group A as well as it's a part of a group B. Now maybe at a group A you have allowed the user, and maybe in a policy you have specifically defined a deny policy, and this user is a policy. In that case the user will not be able to access it. So in that case, in case you want to find out why the user is not able to, you need to check whether you have explicitly denied you are having any deny rule on. So always this is just basically you will not do such kind of things. That is, on a single place you will allow and another place you will deny. You will not do all these things. But in case you need to, as a solution architect, you need to know that deny always takes the highest priority.
Good.
If
yeah, I got it.
Access the data, then you need to check whether you have explicitly denied any users to have access to the service or not. Just for the information, just for the knowledge purpose, this is for you. That is, deny will get the highest priority.
Yeah, highest presence is always denied.
Correct. So this is basically your IAM service. Let's do this on AWS console.
The service one IAM is completed, right?
Yes, IAM is very small.
Yeah.
You can search for service IAM. So now you can see this is my IAM dashboard, and there are few users and roles are there. In your case, might be everything is into alert box. So let's see first how to create a user. Let's click on add a user. Let's get test one. Now, at the same time, if you want to create multiple users, you can create it multiple users. Now, what
if you go back to the AWS console management
here or here?
Yeah, under services, it's the AWS console management, right?
You have to just search for IAM.
How did you get to the console management screen?
Basically, I have logged into the console management screen. That's why.
Oh, okay, that's a separate login. Got it.
Yeah. So once you create an AWS account, then you will have access to it. So here I'm on the dashboard, and here I'm creating a add a users. So let's say Lalit. And then what kind of access do you want to give? Now there are two types of access. One is a programmatic access. Second one is the AWS Management Console access. Management Console access is something which you are seeing right now. Using this web browser tool, you can log in and you can access to the services. The programmatic access gives you access key and secret key. And using this access key and secret key, you can access the AWS services via API, CLI, or SDK. So if you want to hardcode the credentials, or if you want to control the system via CLI, then you will require access key and secret key. So what kind of permissions you want to give, you can define it here. Let's say I want to give both the permissions. And you want to reset the password for the first time. Whatever is your scenario, you can just go ahead with that. I click on next permissions, and permissions I can attach by 3 ways. Groups, I can add a user to an existing group if I have, or I can create a new group. If I have an existing user on which I have specifically defined a particular permissions, then I can copy the permission from existing users here, or I can attach an existing policy directly. Now these are the AWS managed policies. You can see this is the AWS logo, and the type is also AWS managed. So basically these policies are either having a full access or no access at all. Like EC2, full access. So if I want to give my users to have access to the entire EC2 section, I can give it. Or I can say read-only access. This will apply to all the EC2 instances. This will apply to all the EC2 instances. If I want to be very, very specific that the user will have only access to only few of the instances, then I need to create my own custom policy. These are the Amazon managed services. So what I will do is I will just create a user without having any permission. I'll just click on next tags, review, and create a user. The user has no permission. And these are the credentials, the access key, secret key, password. You can just download the CSV here. Close. So we got a Lalit user who doesn't have any permissions as of now. Again, if you want to add a permission, you can just add a permission here. You can add the user to a group directly. Let's create a group here. And group call it as admin. Now on a group level, if you want to attach permissions, you can attach the permissions here, S3 full access, RDS, S3, whatever is your permissions, you can define it here. Let's say again for this moment, we will just skip this part. And I'm not attaching any permissions here. So we have created a group called as admin. Let's add our user to this group. Right. So you can add many users, you can remove the users, whatever it is, you can do. And still, if you see the permission, there is no permissions attached as of now. Let's create a custom policy here. So if you are familiar with the JSON language, you can start writing the JSON language here. The version is 2012 10.17, the latest one. And you can start writing the JSON part, whatever the permissions you want to give. Or you can use a visual editor for easy access. What permissions you want to give, you can access to, or you can define those services. Let's say I want to give access to the EC2. So I search for EC2. What permissions you want to give? List only permission, read only permission, write permission, exactly what. You can be very specific in these terms as well. In the write, what exactly write you want to give? There are various actions are available. So what exactly write permissions you want to give? You can be very, very specific in these terms. Let's say I want my users to start the instance. They can stop the instance. And they can see the list of instances, that is describe instance. So these are the three actions just I want to give to my user. Now on a particular resource, that is on a particular instance, you want to apply this permission or to any instance. If you want to be very specific, you can add a group of all the instance ID here, or you can just say all resources. So one permission is created here. You can see now the JSON document, one permission is created. Similarly, you can add multiple permission in a single policy as well. Let's say S3, and the user will have list access, read access, and let's say write access to all the again buckets. And you can see here the JSON will be automatically written. Whatever the permissions that you have allowed, it will be automatically written here. Let's review the policy, give a name, let's say custom policy, lab 1. And we create a policy. This is our own managed policy. Now this policy I can attach to any users or at the group level. So the group that we created will attach to that group. So I click on attach policy and I search for the policy which I just recently created, custom policy lab 1. So the principal will automatically become now the group. We haven't defined the policy permission here. Principal. Now the principal is automatically a group. And whatever the users is attached to this group, they will also have access to this policy. You can just go to the user, Lalit, and check the permission is automatically attached. Attached from a group, custom policy 11, manage policy from a group called as admin. So this particular user is already having those permissions now. In case if you want to add a specific permission to this user only, you can add a permission. Let's say this out of the user, this user should also have access to the RDS. So this particular RDS permission is only attached to this Lalit user. In the group, still the permission is not attached. So group will not have such kind of permission of having access to the RDS. Only this Lalit user will have access to the RDS. So whatever at the user level or at the group level, whatever the permissions you want to give, you can assign it here. Now similarly, you can create a role. A role is between AWS services. So here we create a role and we need to assign it to one of the AWS service. So you can search for the what exactly services on which service you want to attach a role. If there is another AWS account who wants to access to your AWS account, you can add a 12-digit account ID and that person will have access to your AWS services. You have a web identity. Web identity is like the Facebook, Google, or Amazon. If these people who wants to access to your AWS account, so when they log into your AWS account, what permissions do you want to allow them? You can define the permissions here. And if there is an Active Directory that you are importing, Microsoft Active Directory or LDAP Directory, then you can provide, you can assign the role here. Let's do on EC2 instances, and we will give access to our EC2 machine that yes, EC2 instance can talk to the S3. So what will attach? S3 full access. So we are creating here a permission and we are giving EC2 instance to have a full access, full control on S3 and hit on create role. So we have created here a role. Now this policy which we attached, now this policy is having a principal called as this particular EC2 instance. You can see that trusted relationship is a EC2 instance, EC2.AmazonAWS.com is the identity. So this is basically IAM service where you can deal with the users, groups, roles, and policy. Any question, any doubt in this particular?
No, I think I might need to see, do a little bit of lab. I guess
Yes.
that's when I'll get more and more questions from my side.
Correct, correct. So once we are done with this lab, once we are done with the sessions, I'll share with you recording so that you can go ahead with that video and do all the last part.
Sure.
And
So,
IAM service is completely free. You will not get charged at all. The number of users, group, policy that you create is absolutely free.
Sure. So Lalit, just a quick question though. Do you have a list of like a course map, like what you're going to cover, or on a day-to-day basis? Do you have that list? I know you're.
Yes.
I can see you like you're well versed with AWS.
So no worries. I'll share with you a list of all the things what we are going to discuss.
Yeah, sure. You know what I'm saying, right? It'll help me to track where I am in terms of say
Exactly.
I've got
Are you available tomorrow? Are you available tomorrow?
Yeah, sure. We will. The way I'm trying to do it is, Lalit, an hour every day, so that next day, next day by the time I come here, I'll make sure I'll complete all of it. It's the first time I'm doing the AWS too.
Yeah. So basically, tomorrow I have a weekend batch in the morning 7 to 9 a.m. the same timing, and in that
Okay.
batch I am teaching to one particular student who is already finished the IAM part and EC2. We have just started the EC2 section, so we'll see the EC2 part here so that tomorrow you will not have any kind of doubts. We all will be on the same page.
Okay.
Okay.
So now we are looking at the EC2 part, right?
Right. So IAM is a very small. This is what you need to know about this IAM: roles, policy, users, and group. That's it. So the next is EC2, which is Elastic Compute Cloud. So very basic question. When you try to buy a server or laptop computer, what are the things you consider?
Memory, hard drive, the processor,
Correct. So
and how much cache that it has.
CPU, correct?
Right.
Then storage.
Yeah, storage.
Next.
The process speed.
Yeah, that is considered into the CPU, the number of what is the processor.
Yeah, that's right. Memory, CPU, storage, and then the cache memory too.
Okay. Cache memory that comes into a RAM, which is again RAM.
Yeah. Yeah.
Then what of the operating system? We do consider that.
Level, probably motherboard.
Yes. Then another another part of a motherboard is your network card.
Graphics card, network card.
Yes. I think that's it. And finally, we have a budget, right? The cost of buying.
Correct.
So when you are buying a computer or buying a EC2 instance on the cloud, you need to again think about all the things. You need to consider all of the things. But there is a slight change in the naming convention. So the RAM and the CPU both together are on AWS called as instance type. And if you remember, we discussed initially the T2 micro, which offers you 1 core CPU, 1 GB RAM. So that is nothing but a instance type. It's a combination of both RAM and CPU. Then on storage, you have a EBS elastic block storage or instance store. We'll discuss later on what exactly it means. Just at the very high level, what names are available on AWS. Operating system on the AWS is called as AMI, which stands for Amazon Machine Image. Network card on the AWS is called as ENI, which stands for Elastic Network Interface. GPU is called as GPU, and in the budget section we have 5 pricing models. So all of these things you need to consider when we are trying to buy a computer or a system on the cloud here again. Let's start with the first point, AMI. And AMI is nothing but a template that gives you information about what kind of operating system you want to put, what kind of applications do you want to include in this case. Now, in short, let's assume there's an AMI. If you use this AMI, then it will install Ubuntu server, as well as it will install the PHP and MySQL. So this particular AMI, when you select, it will create a Ubuntu server and it will automatically include PHP and MySQL in that particular server. Maybe there is another AMI which will have only plain Red Hat server. There is no package at all installed. Another AMI which will include Windows. Another AMI which will have Ubuntu, and on top of that there is a WordPress installed. So AMI is nothing but a a package of your operating system and the another application services, whatever it is. So similarly, on your AWS console, you will find thousands of AMIs available. Thousands of AMIs are already available. Certain AMIs are pre-built from the AWS side. These are available. There are certain vendors who have released their own AMIs. For example, Trend Micro Cisco, Trend Micro Deep Security. So this particular company has released their own AMI, and if you pull this AMI, if you use this AMI, then you will have a server with the automatic deep security enabled. Whatever the cost of this particular software, that will be automatically included with this AMI. So for the number of hours that you will run this AMI, you will be get charged. Let's say there is an AMI which will install Windows machine and Oracle database. So whatever the cost will be of the Windows as well as Oracle, it will be applicable to that particular AMI. So it's a combination of the resources as well as the operating system. The different vendors have released their own operating system, own AMIs, and if you use these AMIs, then whatever the charges will be based on the licenses, you have to pay. And the third one is the custom AMI, where you can also create your custom AMIs. If you want to be very specific that you want a Ubuntu and with maybe certain Python libraries or something like that, you can also create your own custom AMI. So the question comes is, when I can create my own custom AMI, where I can use it? Do you have any scenario where you can use your own custom AMI?
I don't know. Probably it could be a specific to an application that we are trying to build. Maybe like instead of going for a native mobile app, either Android or iOS, probably if we want to create our own hybrid app, that's a combination of a hybrid app that has some front end that requires a different operating system or different packages that are required.
Correct.
Maybe those are the.
So for example, let's say I want to boot 20 servers. And I need to make sure whenever I boot 20 servers, it should have a Ubuntu, and along with that, it must have a Java install. It must have a Python as well, and certain other repositories, libraries also. So every time I create a new EC2 instance, I need to deploy all the things. I need to create a Ubuntu server, then I will, pass the command to install the Java, pass the command to install the Python. I need to make sure that everything it will download, every time it will download, and make sure that my servers are up and running. So this will take a lot of time to configure your server with Java and Python. So instead of this, what I can do is I can create my own custom AMI. Once I create an AMI, this AMI will already include the information which is required to boot a Ubuntu server, Java and Python. Whatever the package data will be there, it will be automatically available in this AMI. So using this AMI, I can launch all the 20 servers, and all the 20 servers, once they are up and running, they will have Ubuntu, Java and Python. They do not require to download it again and again. The time to download it again and again will not be required. That data is already available in that AMI. So for the reusability, repeatability of your data, you can use your AMI. Now we have an AWS service called as auto-scaling, which we'll discuss it later on. What exactly is auto-scaling is configuring your environment in such a way that whenever there is a high requirement or low spike is there, it will manage the number of servers at the back end. If you are running 2 servers as of now, and if you are having a high spike which requires 2 more servers, then automatically it will create 2 more servers for you to make sure that you have a sufficient resources running at the background. It will make sure that it will create 2 more servers. In case there is a very low spike, when you are running 2 servers already, and if there is a low spike, then it will turn into one of the server and you will get charged for only having a one server. So based on your requirement, based on your traffic, it will increase and decrease your size of your infrastructure to make sure that your services are up and running available to meet the requirement. So in this particular scenario, when it requires to get two more server, here when I specify use this AMI, then the time to boot this machine will be reduced. Because at that time when in auto scaling, when there is already high spike, it will not download the packages again and again. The data is already available, and once I select that AMI, the data is already a part of it. So again, when it comes to the time required to boot a new server, the time can be reduced, the time can be shortened by having your own custom AMI. Now, companies do not allow you to have access to all the thousands of AMIs on your AWS account. Because what happens as a solution architect, when you create a users in your system and when you give them permission to have access to EC2 instance, these person can launch any machine. I have seen in my career, many people have launched unnecessarily any EC2 instance. They go with the Windows, they go with a Red Hat, and they launch the servers. And you will never come to know that this person have released or created this kind of operating system. And after the end of the month, when you get a bill, you will come to know that these users has created the Windows machine and Red Hat servers, which include licenses. Then you have to pay all the big price here. So what companies do is they restrict the users to have access to only one particular AMI. These AMIs are called as golden images. This is just a term in a environment, in a company organization. They are very restricted to a single golden images, and you are only allowed to use only this particular AMI for all the testing environments, production environments, staging environment. You have to just go with this AMIs. So that whatever will be the cost will be under control.
Yeah, similar to in organizations when we have an operating system, instead of going for different versions of the operating system, whatever is being fully vetted and thoroughly tested, we create an image, and every time a new laptop comes in, just
Yes,
gleaming.
exactly.
Yeah.
So in my case also, in my career as well, I have seen many people have released their, they go with a Windows machine, they go with a Red Hat machine. At the end of the month, we come to know that this is a cost associated with it. So it's better to go with a custom AMI. And in the policy, when you define the permissions, you can define the AMI ID, which AMI ID they are allowed and which AMI they are not allowed.
Got it.
Even there is an option of license manager. In AWS, there is a software service called as license manager. And using this license manager, you can control the licenses, the number of license a system, an AWS account can release. So if you have purchased for the 20 servers, then you will be only allowed to create a max up to 20 servers. Any user trying to create a 21 server, that will not be allowed. So license manager options is also available. Not particularly to our operating system license, to varieties of licenses. So this is an AMI, which is nothing but a template that gives the information about all the system that you want to run. The second is instance type. And in this instance type, you have 5 different categories here. First is general purpose. Second is compute optimized. Third is memory optimized. Fourth one is accelerated computing. And fifth one is storage optimized. Now these are just a category. General purpose category is used for a normal workload. You may want to run a simple web app application or e-commerce site. For a normal workload, you can just go with the general purpose that will give you balanced performance as well as balanced cost. In a scenario where you will require more CPU than your RAM power, you can go with the compute optimized category. Here you get more CPU power, maybe for the batch operations, maybe for high performance computing, scientific calculation, where you will require more CPU power. You can choose this category here. If you require more RAM, more IOPS for your database services, like you may want to run a database on your EC2 instance, a big database, when you are having a frequent input-output operations per second. At that time, you require more RAM capacity. At that time, you can consider memory optimized category. Accelerated computing offers you GPU power. If you want to have a GPU on your EC2 instance, then graphics card, then you can go with accelerated computing. Maybe for gaming applications, for blockchain network, or 3D rendering, for machine learning, for all these scenarios where you will require a GPU, you can go with this category. And storage optimized category gives you more throughput. So if you want to deal with a high database, a huge amount of data, which requires a frequent input and output, faster reader and write operations, at that time you can go with the storage optimized category. These are the 5 different categories are available on the AWS. Now in each of these categories, there are subfamilies there. The families are like T2, T3, C5 family, C7 family, C5A family. A varieties of families are available. So what exactly it is? This T represents one of the processor. This T represents one of the processor. So here in the general purpose, T represents Intel Xeon processor, and 2 represent the generation of the processor. So T2 micro, T2 category says Intel Xeon processor of the 2nd generation. T3 Intel Xeon processor of the 3rd generation. This may be AMD processor, this may be another processor. So in this case, again, you have varieties of subfamilies. Each families will have again varieties of configuration. Like if you talk about the T2 micro, T2, then you have a T2 nano, which gives you 1 vCPU and 0.5 GB of RAM. You have T2 micro, which offers you 1 core CPU and 1 GB RAM. You have then T2 small, which offers you, I think, 1 core CPU and 2 GB RAM. So again, you have varieties of configuration here. And you need, whenever you create an instance, you need to choose one of the instance type. Whether you want a T2 micro, T2 nano, T2 small, anything. At any time, you can upgrade your system as well. If you have choose the T2 micro, and then you figure out that you don't require T2 micro, you need to move it to the T2 small, then you can go it easily. You can upgrade your system, or you can downgrade your system whenever you want. From T2 micro to T2 small or T2 nano, you can easily do that. Okay. Any questions? Is this right?
No.
All right. Then we have a storage part. And in storage, we have EPS or instance store. Do you know what is block level storage?
No.
Basically, a block level storage is a kind of storage system where the data is stored at the block level on your drive, on your hard disk, whatever is there. The data is stored on a block level. So if you see your laptop, your computers, or your mobile device, or any electronic device which holds the data, it is nothing but a block level storage. A block level storage helps you to boot your system or to install applications. For this, you will always require a block level storage. Only block level storage will help you to boot your system and install the application whatever is required. If you are Android user, then you will have, this there is a root directory, and this industry data you have application directory and all this directory. So this is only available in the block level storage. So we have first of all instance store, and instance store is nothing but a non-persistent storage system. That means whatever the data that you will upload on the instance store, that will be a temporary data, that is a ephemeral storage system. Once you reboot the machine, once you stop the machine, or in case if the EC2 machine fails to perform, then whatever the data is attached to this instance store, that will be completely lost. This is a non-persistent storage system. This is just a temporary storage of a data. So in case if there is a failure occurs in your EC2 machine, or the EC2, if you stop the EC2 machine manually, then whatever the data that you have stored will be completely lost. The second one is the EBS, which is elastic block storage, and this is a persistent data storage. No matter how many times you restart your machine, you stop the machine, your data will always persist unless you manually delete the data. The data will always persist. Now in this EBS, again there are two categories available. One is SSD and second one is HDD. Do you know this name? Have you ever heard of solid state drive and hard disk drive?
Yeah, of course.
So solid state drive is used for the booting purpose, and HDD is not used for the booting. It's just for the storing of a huge amount of data.
Correct.
Laptop.
Apple's come with SSD, and the rest of the Windows operating system based computers use HDD normally.
No, basically all the system which are booted is on the SSD. Even your Windows are booted on SSD volumes.
Correct. My point is, Apple majority of their drives are SSD, solid state drive.
Yes. And what if the mobile phones that you have? These again are on the SSDs.
Yeah.
So you have SSD on the AWS as well, and SSDs are available in again two categories: general purpose and provision IOPS. General purpose is again for the normal workload where you get a balanced performance for the balanced cost, whatever you go. Provision IOPS, here you can provision the number of input-output operations that you will require per second here. Maybe you want to run a database. So for a database, you will require a provision IOPS. In that case, it is very well suited because you are going to have frequent input-output operations. You read requests, you many times read requests, write requests. So at the time, you will require more IOPS operations. So in that case, you can go with the provision IOPS. Here, the cost will be definitely a little higher depending upon the number of IOPS you go. Then you have HDD, and HDD, you again have two categories. First one is throughput optimized, and second one is cold HDD. Comparatively, the cost of HDD is lower than SSD. HDD is just like your pen drive or external drive which you have right now as well. So throughput optimized gives you more throughput power, so that if you have huge amount of data that you want to access the data, at that time throughput is very well suited for streaming of application or for storing big data, big applications data. For such kind of scenarios, throughput is very useful. In this case, you need to always remember, if you are having a frequent access to the data, you should consider throughput optimized. If it is less frequent to your access, but you require a connected service, you can prefer a cold HDD. Cold HDD is again low cost storage system. At the very high level, this is not related to the AWS, this is in general. A storage can be a variety of types, like direct attached storage system. Direct attached storage system is that storage is physically connected to your device. You have a network as a storage and storage as a network. Network as a storage is like For example, Google Drive. Sorry, network and storage is like FTP server. So in a particular network, what if the number of services are available, number of computers are available, all the services can fetch the data. It's just like your FTP. And software as a network is like a Google Drives or iCloud service, SkyDrive, whatever you have. All these drives are nothing but a storage as a network. And then you have a direct storage system, which is like your EBS volume, which is physically attached to your system. So here, this EBS is also direct data storage system, which will give you more throughput comparatively to your network and the software as a network. On AWS also, you have a NAS-based storage system, which is called as EFS. You have a SAN-based storage system, which is called as S3, which we'll discuss it later on. But right now, EBS is a direct data storage system, which means physically the system is attached to your device. All right. And one important point, when you go for a general purpose, you can start from minimum of 1 GB. Maximum a single volume can grow till 16 TB. And you can create n number of volumes. So again, you can store unlimited number of data, but a single volume can extend to only 16 terabyte. For provision IPS, minimum of 4 GB, maximum 16 terabytes. Here the requirements start from minimum of 500 GB, maximum 16 terabytes again. And for cold HDD again, minimum of 500 GB, maximum 16 terabytes. All right, this is all about the EBS. Hello, Ravi, you there?
Sorry, my microphone is muted. Yeah, I am here.
Now, this is very small concept about the EBS is snapshot. A snapshot is nothing but a backup of your EBS volume. Now, by default, AWS will take a backup of your volume. AWS will automatically take a backup of your volume, and it will be stored in the same memory zone as you create in your machine. If you create an EBS volume in AZ1A, in the same AZ1A, there will be a replica of your data, which has been taken by the AWS at the backend. Now, this replica copy will be only used in case if there is a failure occurs in the AWS data center, or due to any reason if the ability goes down, then to recover your data for that purpose only, the replica can be used. But in case if you lose your data from your side, if by mistake you have deleted the volume and if you want to restore the data and if you request to the AWS is not going to help you. AWS will only create a replica in case if any kind of mistake or if there is a loss of data happens from the AWS side, then only this replica will be used. Apart from that, if you lose your data from your side, AWS is not going to use or help you with that. For that, what options do you have is take a backup of your volumes. And these volumes backups are incremental in nature. Do you know what is incremental backup?
Right.
So let's take a scenario. What is incremental backup? Let's say I have 10 GB of volume. So I take a snapshot here, and here snapshot A will be created. Its size of 10 GB. Let's say tomorrow I have made modifications in this 10 GB. 8 GB of the data is still remain the concept, and I have modified 2 GB of the data. So on the another day when I'm trying to create a snapshot B will be created. Now snapshot B size will be only 2 GB. Whatever the delta change is there from snapshot A to snapshot B, only the change of the data will be taken place into a snapshot. Here, still 8 GB of the data which is still constant in the snapshot A, that will not be taken as a backup. Only whatever the changes is there, that changes of our data will be taken into the place. You don't need to deal with all these things. AWS will at the backend will check what is available in the snapshot A and what is available in the snapshot B, and only the delta change will be taken here. So instead of you pay here for a 10 GB and another 10 GB for a snapshot B, now in total you will pay only 12 GB of the snapshot. Let's say you have added 2 more GB of volume. So you have initial 8 GB, then you have 2 GB of modified content, and now you have added 2 more GB of data. That is 12 GB of volume size. And if you take a snap now, then snapshot C will be created. And the size of the snapshot will be again only 2 GB. Whatever the changes is there of the 2 GB, the additional volume, the size will be only there. The rest of the content of the 8 GB and 2 GB will be referred from the snapshot B and the snapshot C. In case if you want to take a backup, if you want to restore the data from a snapshot C, you can do it and all this information will be delivered to you. If you restore the data from a snapshot B, then all this information will be again delivered to you. Whatever the 8 GB of older data and 2 GB of a new data, whatever there is the case, it will be delivered to you. So here my question comes, what if I delete this volume? What if I delete this snapshot?
Only the data that is part of snapshot A will be deleted, but B and C will be still intact.
So in this case, if I delete a snapshot A, and if I want to restore the data of a snapshot B, what data I will get? So always remember whenever we talk about, yes.
See, snapshot B is basically the difference are the newly added data is being created as snapshot B, right? Which is the additional 2 GB data.
Correct.
Right. So if snapshot A, which is the originated our original drive data is corrupted or deleted, the only data that lasts is the newly added data on top of the 10 GB, which is 2 GB data will be restored, but rest of the data will not be available.
Okay. So in terms of incremental backup, what exactly it means? That whatever the data changes there from snapshot A to snapshot B, the amount of data will be stored.
Correct.
Like the unchanged data will not be stored here. That is, in the snapshot A, you have a 8 GB of unchanged data. So unchanged data will not be copied in the snapshot B. Whatever the changes will be there, only that amount of GBs of data will be stored here. So in case in our scenario, if I delete a snapshot A, then what will happen? The unchanged data of a snapshot A, which has been used in the snapshot B, that will be moved to the snapshot B. So if I delete the snapshot A, the referred data, whatever the reference is there to the snapshot B, the data will be shifted to the next snapshot. So in this case, the 8 GB of referred data will be shifted here. And whatever the 2 GB of older data copy will be there, that is been deleted. So the size of the snapshot will again become 10 GB. What if I delete a snapshot B? If I delete a snapshot B, then this 2 GB of a data will be shared to the snapshot C. And whatever the 8 GB of record data is also available, that is shared to the snapshot. So whenever you delete a particular snapshot, the data is basically shifted to the next snapshot. So that in case if you want to restore it any point of time, you can easily do. There's no loss of a data at all. Okay.
Yeah.
So with this snapshot, there's no loss of a data. It just gives you benefit that from storing the amount of GBs of data. Instead of having a 10 GB of volume, 10 GB of another snapshot B, and 12 GB of snapshot C, that is total of 32 GB, you here pay only for the 14 GB of storage. 10 plus 2 plus 2. So here it gives you benefit here.
Got you. That's the incremental snapshots advantage.
So we have covered the instance type, volumes, operating system, GPU is already we have seen in the instance category, that is accelerated computing. Now what we have is the ENI and the pricing model. ENI stands for Elastic Network Interface. So first question is why you will require a network card? What is the use of network card?
To connect to network, whether it is a Ethernet card or Ethernet cable or wireless.
Exactly. To have to the internet, you will require a network card.
Correct. To communicate with other computers or to have an established relationship with the other devices via network, we need a network card, our network interface card, NIC.
Correct. So here you get one public IP and one private IP. Do you know the difference between public IP and private IP?
I know, but I don't know how to explain that. Go ahead, please.
Yeah. So on your system, what you have right now? Do you have a public IP or private IP? In general.
I'm sorry, what can you repeat the question, Lalit?
Yeah. On your laptop, computer, mobile devices, what IP you have? Do you have public IP or private IP?
See, when I'm using my router, I'll have my router's IP, which is more of a private, but the public IP is the gateway or the provider's IP, which I'll have.
Absolutely. So basically, anytime whenever your device is connected to the internet, you get one public IP. This public IP is given to you by your internet service provider.
Correct.
And this public IP is basically internet-based internet IP. So that whatever the download uploading you want to do, you can easily do with the public IP. If you do not have public IP, you cannot interact with internet. Now these are dynamic IPs. These are dynamically assigned to you, randomly assigned to you. Whenever you get to a network, you get a dynamic IP. Every time you change your computer or you change your network or you restart your machine, you get a different IP. In terms of private IPs are internal IP, which is defined to you, which is given to you by your router. For the internal communications only, private IP is assigned to you. And these private IPs are static. This is usually never changes. This is always stick to your computer. If you want to have a communication over the internet, you must have a public IP. Right now as well, your system and my system is connected to a public IP and we are changing the data over the public IP. This GoToMeeting, whatever the medium it is, we are sharing our data over this protocol of a GoToMeeting. So my public IP is talking to your public IP. Yeah. And private IP is for the internal purpose only. You cannot have access to the internet. You cannot have a communication over it. Just for the internal communication, you can use it. So here we have a scenario. Let's say I have a domain, example.com. This domain is configured with one of the public IP of my EC2 instance. So whenever the request comes to my domain.com, this IPs get hit of my EC2 server, and whatever the application is running, the data will be shown to the user. This is usually how you configure the server with your domain. So as you know, these public IPs are dynamic IP. So in case if my EC2 instance restarts, then the public IP will also change. And if the public IP changes, then the communication between domain and EC2 instance will be closed. There will be no communication between domain and the server. So in that case, whenever the request comes, the domain will not respond to that request. So how will you do? So in that case, how to make sure that there is no communication break between server and domain?
So the EC2, we may want to use the DHCP static address so that it doesn't change the address every time it goes.
Yes, but you do not have that option. You have either a private IP where you cannot have a request coming from a domain from the internet, This is only for the internal. And when you have a public IP, this is basically dynamic. So it will change the IP address here.
Okay.
So then the third option that you have, which AWS offers you, is Elastic IP. Elastic IPs are internet-based IPs. You can have access to it. These are nothing but a public IP, but not like static. But not like dynamic. These are the static IP. These IPs address are allocated to your AWS account, and it never leaves. Unless you delete that IP, it will never leave your IP. On AWS, public IPs are free, private IPs are also free. You will not get charged. But Elastic IPs are highly chargeable. And the charges depends on the various factors. First is like if it is connected to a running machine, running EC2 instance, then you will have normal charges. Whatever the minimal charges there, you have to pay. Second, if it is not connected to a running machine, then the charges are very high. Because this elastic IP, the static IPs are very, sacred. These are very less. So if you are just created this elastic IP and if you have not associated to any running instance, then the charges are really very high. So first of all, you need to make sure whenever you go with elastic IP, it is connected to a running machine. Now the second condition is you can only create 5 elastic IPs per region. We cannot have it more than this. In case if you want to have, again you have to request to the AWS, they will increase the limit. So there's a request, there's only limitation that you can create 5 elastic IPs by default. So in this case,
5 elastic IPs is the maximum number of IPs that we can get it per region.
Right.
Okay.
So in our scenario, we have a domain and our public IP gets hit to EC2 instance. Now let's say I have 10 server running. Of course, I am using the EC2 instance for a big production account, not for the small 1 or 2 EC2 instances. So in this case, if I have 10 EC2 instances running, I cannot have an elastic IP associated. If I associate 5 elastic IP, first of all, the cost will be increased. Correct? The cost for designing the infrastructure will be increased because elastic IPs are highly chargeable. Second, if I have more than 5 EC2 instances, then I cannot attach to all the EC2 instances elastic IP. So in that case, what you will do?
No idea.
Okay, not okay.
Create these in different regions so that you can create two regions, and then each region you'll have 5 systems or 5 are the static IPs, and then you can share those through the load balance.
Hundreds of servers.
Yeah.
So having a public IP or elastic IP is not a good solution. So what I request you is to just take a note of this question. What problem we have is domain connected to the number of EC2 instances, and we need a connectivity method. The solution we'll discuss in our next lecture. Right now, we are not going to deal with this solution.
Okay, sure.
All right?
Yeah.
And
so tomorrow,
tomorrow, more probably, yes, sure.
Yeah, and tomorrow is at 7 o'clock your time or 6:30 your time?
7 o'clock my time. Same time.
Okay.
Now to a single instance, you can add multiple ENIs as well. You can have multiple network cards where you will get multiple public IPs, private IPs to your system. And finally, we have a pricing model. And in this case, again, we have 5 pricing model. First is on demand. Second one is reserve. Third is spot machine. Fourth is dedicated instance. And fifth one is dedicated host. On demand means pay as you go. If you want one server for 4 hours, whatever the cost will be, you have to pay. Whatever the current demand, whatever the current price of that on-demand server will be based on the instance type, you need to pay for that. For the number of hours that you will be consuming, you need to pay. Reserve instance is very good for the production infrastructure. When you know that this particular instance type you will require for the next 1 year, 1 or 3 year, the term is only for the 1 year or 3 year. If you know that this particular EC2 machine, let's say T2 micro machine, you will require for your system for the next 1 year or 3 year, you can reserve the machine. You have to pay the upfront here, and you will get up to 60 to 70% of discount. Up to 60 to 70% of discount on your on-demand price. In case if you reserve the machine for the next 1 year or 3 year, you get up to 60% of discount, and this discount depends on how you do the payment. If you do that complete payment, then you will get the maximum discount. If you do the partial payment, your discounts varies accordingly. The term here is only for the 1 year or 3 year. You do not have a term 2 year, 4 year, 6 year, anything like that. Only 1 and 3 year. Now to understand the spot is really a little tricky. 1 second. Let's assume this is the AWS data center. One of the regions, AWS data centers, where you are having your resources up and running. Let's assume these data centers can have thousands of T2 micro machines. This particular hardware can create thousands of T2 micro machines. Now there's a customer A who has requested for a T2 micro machine, few T2 micro machine. So AWS has reserved those capacity on hardware. This is for the customer, let's say 01. Similarly, there is a customer B, customer 2, who has also requested for the few number of servers, and AWS has allocated them. Now this number of servers may be an on-demand, may be a reserve. Let's say the on-demand price right now in the Mumbai infrastructure is let's say $1 per hour. So you will get a reserve instance approximately, let's assume $0.4 per hour. Now here you will get a spot instance for a price of approximately $2 per hour. Here you can get up to 90% of discount. To 90% of discount. But these are the not reliable servers. What does that mean? So let's say there is a customer 1 who has requested for an on-demand server, and the person has got the number of server which has requested. Similarly by customer 2s, customer 3s, and customer 4s accordingly. So let's assume these are the different AWS customers who has requested for the multiple servers, and total they have consumed 50% of it. Out of the 1000 capacity, 500 T2 micro machine is already being consumed. So what Amazon left is 500 another servers which are still idle, which has not been used at all. So they are offering you this unused capacity of AWS up to 90% of discount, which is for the, let's say for $0.2 per hour. So when you request to a spot instance, you need to bid on certain price. Let's say I need a server till the cost reaches to $0.35 per hour. Basically, the spot prices will change over the period of time. As the demand increases, the supply decreases, and the cost of a spot increase will also increase. Let's say right now you have 500 T2 micro machines available for idle. Let's say the different AWS customer has increased the limit. So the demand of an on-demand is the reserve instance. Now the supply is reduced. When supply is reduced, the cost of a spot instance will automatically increase, maybe from 0 to 2.25, 35, whatever it is. So once the price of a spot machine reaches to your bidding threshold, here you will get a notification. First notification will be that your bidding price has reached to the spot instance threshold. You can increase the bidding price here. Otherwise, you will have 2 minutes now to take a backup of your data. Otherwise, the server will be automatically get terminated. And that's why spot machines are not reliable. You cannot guarantee that the server will be always available to you. It totally depends on the cost, demand, and supply. If the demand increases, the price of this machine will also increase. If it reaches to your threshold, then you will get a notification that you can increase the bidding price, or you can take a backup of your data. Otherwise, the server will be terminated within 2 minutes. So why you should have a spot machine? You can go with the spot machine only for testing environments where you don't want to spend a lot of money. For such scenario only, spot machine is very well suited. You can get up to 90% of discount. Right? Did you get the scenario? What is the unused capacity of AWS and how the cost varies?
Yeah.
All right. So basically, on-demand, shared, on-demand, reserve, and the spot machine. These three are the shared resources. That is on a single hardware. Different AWS customers are sharing their resources. It doesn't mean that their data is also being shared. Whatever the data you upload on your single EC2 machine, that is completely isolated at the very kernel level. Whatever you get a completely isolated environment. So there is no sharing of a data at all. Now you have a dedicated instance and dedicated host. Dedicated instance means you get a completely dedicated EC2 machine on a private hardware. You got a single instance on a dedicated hardware.
More of a private cloud, I guess.
Yes, more likely private cloud. And here, dedicated host means you get an entire hardware dedicatedly available to you. Now it's up to you how many instances that you want to launch. You can launch in this particular hardware 1 server, 2 server, and number of servers based on the capacity of the server. So that is dedicated host. Now definitely the cost of a dedicated host and the instance is comparatively higher than what you have as a shared one. Okay. Any question, any doubt in this part?
No.
All good?
Yeah.
This is a theory of all the EC2 instances, whatever you will require to launch a server. Now, what machine do you have? Do you use a Windows machine or Linux Mac machine?
No, I use Mac, but I do have a Windows machine too.
No, that is fine. It doesn't matter actually. So basically, when we are launching the system, the server remains the same. Just connecting to the server changes. How you connect to that server is a different procedure. So you have to just go for the EC2 instance. I think it's already a time. I'll just show you how to connect to a Linux machine. Windows machine will see tomorrow. Is that fine?
Yeah.
So you have to just go to the EC2 instance so that you can try today, so that tomorrow you will be able to do it. So you have to just go to the EC2 instance dashboard, and here you will find all the resources. Right now it's 0, 0. To launch a machine, you have to just click on launch instance. And the first step is to choosing an AMI, which operating system you require. Now here you can see a list of very big list of AMIs available. And you should only go for a free tier eligible right now. As long as you are in a free tier eligible, you should go for these machines only, so that you will not get charged for the licenses. Like here you get a Windows license for free here if you use this particular AMI. Here you have an AMI called as Amazon Linux 2 AMI, which offers you a Red Hat machine with the easy to install System 219 GCC compiler and a few other things. There is another AMI available which offers you pre-install of CLI, Python, Ruby, Perl, Java, repositories like Docker, PHP, MySQL. So you don't require to download all these things. It is already a part of it. Similarly, you have Red Hat, Choose Linux, Ubuntu Server, all these things. If you have created your own custom AMI, then you will find it here. You have a marketplace where different vendors have released their own operating system and application software as a part of it. So you can see various of categories here, various of companies have released it. You can just search your product. And then you have a community AMI where you will get a various versions of your operating system. Maybe I want to have a Ubuntu server with 64-bit architecture. So here you get a dip list of all this operating system. Ubuntu 18, Ubuntu 16, Ubuntu Xenial, Ubuntu with deep learning, which includes NVIDIA, CUDA, all these packages. Various of options are available. So whatever is your scenario, you can just go ahead. I'll go with the basic one, Amazon Linux to AMI. The second step is to choose the instance type, the hardware. You can choose the hardware. It's better to go with the T2 macro, which is free tier eligible, which offers you 1-core CPU and 1 GB RAM. Next, here you can configure all the details regarding your instance, in which VPC you want, in which subnet, public IP, and all these things. Right now, at this moment, we will not touch anything. Once we see the VPC part, then we will configure everything. Add storage, one important thing. You remember we created a role.
Right.
That role was we created for the EC2 instance to give a permission to the S3. Now, as of now, these EC2 machines do not have permission to talk to the S3. But the role that you have created, you can attach that role. That is EC2 S3 full access. If I attach this role, then this EC2 machine can talk to that service. I'll show you. Right now, I have not attached, it's none. Add storage. The amount of GBs of data which is required, you can add it here. Tag, you can add a tag, names to your server and etc. Tags plays a very important role for filtration, for managing of the resources, for sorting out the resources, plays a really important role. And lastly, you have a security group. Security group defines which ports do you want to enable and which ports you don't want to enable. Now, by default, in a security group is nothing but a firewall, okay? The firewall which you have as an on-premise, now the virtual firewall is called as security group. Firewall, by default on the AWS, everything is denied. Again, the deny will get the highest priority here. Here, deny will always get the highest priority. So all TCP rules, all UDP ports, whatever you have, 0 to 65,000 and further UDP ports, everything is denied. Every single port is denied. You need to specifically define which ports you want to allow. If you want to have communication on port 22, port 80, port 3389, whatever the port it is where you are having a communication, you need to open it wisely. You need to explicitly
define the policy, though, right?
No, you don't need to define a policy. In the security group, you can add a rule.
Oh, okay. You can add it here. Got it.
Yeah. So I'm creating a new security group, and in this Linux security group, I have named it. And here I'm just opening the port SSH. That is 22 port for having a remote access to your computer. You need to open the SSH port. If it is a Windows, then you need to open the RDP port. So these are the two different ports for connecting remote machine. Even here, in this case, you can define the source from where the request should be coming. If the request is coming from this particular source, then only the request will be accepted. So here you can define your own organization IP address. So if you want to restrict whenever the team member is in the office, then only it should be connected to the server. If it is connecting from home or from other location, then it should not connect it. So if you have such kind of condition, then you can implement that. You can set it as anywhere where every 0000, that is anyone on the internet, can access to this server. Or you have third option of my IP, where it will fetch your public IP, whatever your system is having a public IP right now. Okay. In case this public IP changes, then you will not be able to access the data. So as of now, I'll go with anywhere 000, and I review and launch a machine. Now lastly, we need to create a key pair. A key pair is nothing but an authentication method to connect to the server. It's just like a password to your server. So you need to create a key pair. So I'm choosing a create a new key pair. You can also attach an existing key pair. Now talking about the key pairs are region specific. Key pairs are region specific, and a single key pair, you can attach it to n number of EC2 instances. That may be Linux, that may be Windows. It really doesn't matter. You can attach it to anyone. Just make sure once you create a key pair, you download this key pair, because the next time you will not be able to create a new same key pair again. You will not be able to regenerate the same key pair again. So first thing, make sure you download the key pair. Secondly, you keep it very secure, because if you lose this key pair, you will not be able to regenerate the content of this key pair. And if you lose this key pair, you will not be able to connect to that machine. So you need to keep it very secure. Click on launch instance. Now here you can see you have got the public IP and the private IPs. Private IPs are not accessible over the internet. Public IPs are accessible. You can copy this public IP and wait for your system to come into a running state. Right now you can see the system is running state. So there is certain command that you need to pass. If you click on connect, you will get a list of all the commands. Now, as you already have a Mac machine, so you can follow directly here. What I'm doing is open your terminal, and you need to go to your download directory where your key pair is available. So I go to my download directory, CD downloads. Here I have that key pair, that is lab keypair.pm file. The first command I need to pass is change permission, and I give to permission to my terminal to have access to that lab key pair. You can find the same command here as well. First is chmod. This is only one time thing that you have to do. Once done, you don't need to do it again and again. Now the second command is to connect to this machine. ssh-i lab key pair, the name of your key pair, ec2-user, which is your username of this machine, @IP address where you want to connect. Hit enter. It will ask you, do you want to connect? Yes. And you can see you are connected to a remote server on the cloud. You can see the IP address 172.31.28.33, which is your private IP address here. So now you have created a server on the cloud, and you have got access to the cloud. You have access to the server. Now whatever you want to do, you can do it here.
Got it.
And let's say I want to install the Apache server. So the command is yum install httpd. httpd is a package name for the Apache. So I hit yes, install, and it's installed my Apache server. I can start the service. Now basically this Apache server runs on 80 port. By default it runs on 80 port. 80 port is your web server. So if I copy the public IP and hit from the browser, I should be able to access my server. If you hit this IP address from your system, you should be able to hit the server as well. But I am not able to get the data. I'm not able to see the content. Do you know the reason why my request is not get fulfilled?
Because by default, all of them are denied, right? We have to open the.
So if you remember in the security group, we have just enabled the 22 port. So
Correct.
that's why we are able to do this SSH. So here we need to also enable the 80 port. So I again go to security group. In the inbound, I will open the port HTTP anywhere from the world. And now if I access from the browser, you can see this test page. If you hit this IP address, you will also find the same data. Now you can just go to this directory and configure your web page there. Right now there is no data at all. What I'm trying to do is I'm downloading one HTML document template from the internet. Let's say this one. I'm downloading this template. I directly download it to my server, wget link. So you can see the file is already available. Now we need to unzip. And we need to extract the data from this file. So I will just say and move the data to where www/html. Now you can see the data which is available in this folder. Now it is available here in this root directory. So if you hit this IP address again, my IP address, you should be able to see your web page. So hosting a website on the AWS is just few clicks. Within few minutes, you will be able to host your application. All right.
Yeah.
So what you can do is just create an AWS account, go with the IAM service and try to launch a server. That's all. Tomorrow we'll see the your Windows machine.
Yeah, sure.
Yeah. So let me know if you have any other questions. Otherwise, we are good to go.
Yeah, sure. Thank you so much.
Yeah, just make sure once you're done with the lab, click on the actions and say terminate. Otherwise, the server will keep on running.
Oh, okay.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Want to study further? Subscribe to our paid membership to get a deep dive into each and every topic. Do look out for more videos in our playlist and subscribe to our DevOpsSchool channel and hit the bell icon to learn more. Keep learning.